something like this. We want to okay, so a problem like this, we want to find the area, the exact area now, under this curve, 27 minus x cubed on the interval where x goes from 1 to 3. And what the questions are going to ask you, there's a couple of these on the homework. What they ask you to do is they ask you to come up with a couple things. They want you to come up with what is, I think there's 3 things. They want to know what's f of x sub I, what's delta x, and then what is the actual area. Okay? And so what we're looking at here is we're looking at setting up a sum of rectangles, right? But then we're going to let the number of rectangles approach infinity and get an exact answer. And so we had this, if you recall, last week we'd gotten to a point where we had a formula for that, right? We said that the area, the exact area, equaled the limit as n approaches infinity of, what was our general, how did we say the sum of all those little rectangles? Well, we know we need a sigma, right? And I is our index variable, which is going to keep track of which, well, we're going to sum up each rectangle, the ith rectangle, as I goes from first one, up to, well, okay, up to n. And then we'll take the limit as n goes to infinity. There's really kind of 2 steps to this. And then we just needed to write down a little formula in here then for the area of a rectangle. But remember, rectangles are simple. They're just height times width, right? Okay. So what's the height of a rectangle, we say? We don't even know what the function is, right? But it's just f of something. There we go. Good. It was the right-hand edge of the interval was the most convenient place. And so that meant that if we started our area that we're adding up under the curve, if we started at x equals a and ended at x equals b and cut it into n little rectangles, then we started at a, and to get to the right edge of the ith rectangle, we just had to take I steps, didn't we, from a? You know, at I steps of delta x to walk over to the right-hand edge of that interval. Okay, so that looked like a plus I delta x. Starting x value plus I increments of that delta x step. And then we're evaluating the function at that x value, and that's the height. And what was the width? Delta x, yeah. So there it is. Right? So that's what our area formula is going to look like. And they're just asking you in a couple of these questions in part 2, they're just asking you to kind of, well, okay, well, what does this f of x sub I look like? What is this part right there? Okay. Well, what if f of x is 27 minus x cubed? And what's a in this case? 1. Good. What's b? Well, here's our interval. 3. Okay, so we're starting adding at the area at 1, and we're ending at x equals 3. So just on that interval, we want the area under the curve, right? So probably the easiest thing to do would be to answer what's delta x first. What's delta x? 2 is the width of the interval, divided by how many rectangles? 2 divided by n. 2 divided by n. Now, if there were, say, 5 rectangles, then we'd have to cut that 2 up into 5 pieces, and each of them, right? Does that make sense? So it's b minus a over n. Then we get 2/5 would be the width of each interval. But this time, we have n rectangles, so we just get 3 minus 1 over n, or 2 over n. Okay, good. Now what's a plus I delta x going to look like? 1 is a, right? There's our a. So 1 plus I times delta x, just 2i over n we could say. And that's what we're going to put into our function. Now what's our function say to do? F of x is 27 minus x cubed, right? What's f of junk? Okay, well there's our junk that we're putting into it, right? So we're just going to get 27 minus that quantity cubed. Make sense? Okay. So there's f of x sub I, right? And if we wanted to find an area, now all we have to do is just plug all that stuff into our limit, right? We have to do some sums though. Okay, so let's see what that looks like then. So we get the limit as n approaches infinity of f of x sub I times delta x, the sum of that, right? Okay, how we can do that? Okay, we got to expand it, don't we? Yeah. Look, we've got i's. Let me make the i's stick out a little bit. So we got these i's. Right there is the only I. Right, and that's the variable of the summation. That's when we sum this thing up. Remember, we got those 4 summation formulas that we'll be able to use, but those are only interested in the i's. Everything else is a constant as far as that sigma is concerned, at least. Now, when we get out to the limit's going to be working on the ends, right? But the sigma is only interested in the i's, okay? So we need to expand this guy out, yeah. So what is a plus b cubed? Do you remember? Remember what that expansion is? A plus that binomial expansion, a plus b cubed?
A cubed.
A cubed. What the next one was?
Is it 1441?
It's a squared b. Good. What's the coefficient? Do you remember? 3. Good. Plus ab squared. Good. Plus. Good. Plus b cubed. Okay. So instead of a and b, we've got 1 and this fraction 2i over n. Right. So we get 27 minus a cubed is just 1. 3 a squared b is going to be, what's that going to be, 6i over n? Is that right? Oops, I don't need the 6 is in there twice, isn't it? Whoops. See what I'm doing there? So this term, this guy right here, that's our a, is 1, right? And our b is this is b right there. And so this guy right here, 3a squared b is going to be 3 times 1 squared times that fraction. So 6i over n, okay? Plus, now what about this guy here? Let's see, this is going to be a little harder. We got 3ab squared. So 3 times 1 times this fraction squared.
So 12i squared.
There you go, good. So 12i squared over n squared. Sounds about right. And then finally we get plus b cubed, so just this fraction cubed. So what, 8i cubed over n cubed? Okay, and then it looks like we've got all this, we got 4 terms in here, or 5, we can combine those a little bit though. We got 2 constants. I need to distribute that negative sign all the way through though, right? So we gotta go to another page, this is getting too crowded. Okay, so okay, so now if we just combine like terms, we're gonna get what, 26 it looks like? From these guys, and then I just have to subtract each of those. We're gonna get 4 separate sums. Oh, I forgot the delta x, didn't I?
Yeah.
Yeah, we need a delta x in there, so I need to have in here, I've got the sum of f of this whole thing right here is, that's f of x sub I, right? But I need to have my delta x in there also. So we need to plug that in like right there. Right? Should just be a 2 over n.
Yeah.
Okay, we'll add it on this line, how about? Okay. So there's my delta x. And you know, really that 2 over n doesn't have any i's in it, does it? So what could we do with that if we wanted to? Okay, we could pull it out in front of the sigma, couldn't we? But we can't pull it out in front of the limit, because the limit, the variable of the limit is actually the n, right? But we could put that, just for convenience sake, we could pull that out in front of the sigma, because the sigma is interested in the i's. Okay? And the only purpose it serves is just to kind of make the algebra a little cleaner, because we're going to end up redistributing it anyway, but it might help a little bit. And then what about these four separate terms? I'm summing 4 terms, and so I can apply the sigma to each one separately, right? I can sum them term by term. So I'm going to have the sum of the first one. So I've got my limit of 2 over n times a bunch of stuff, right? I got the sum of 26 as I goes from 1 to n. Well, what is that? 26n. Okay, so the first sum becomes 26n. Good. Now what about the second one here? On the second one, I've got minus six over n times the sum of I. Do you remember what the sum of I was? From 1 to n? Probably not. I think it was n times n plus 1 over 2. Does that sound right? Okay. And then we get this third term. I'm going to get minus 12 over n squared times the sum of I squared. Remember that one? N times
n plus 1 times 2n plus 1.
There you go. Over 6. Good. And then run out of room here. Finally, we get the minus 8 over n cubed times n squared times n plus 1 squared over 4. Is that right? Okay. Okay, so it's kind of a mess, but it's starting to look better. It's actually, things are going to start to cancel now a little bit. Look, we can cancel those n's. That's kind of nice. We can cancel one of those ends. That's good. And we can cancel two of those ends. Okay, that's all good. And then we can go ahead and distribute that 2 over n. So if I distribute the 2 over n to this first one, what am I going to get? Yeah, 52 n over n, right? The n's are going to cancel. Everybody agree? So when I distribute here, 52 n over n, the n's cancel. So the first term is 52. Minus, if I distribute the n here, I'm going to get, let's see, 12 over 2, so I'm going to get 6. And then I'm going to get n plus 1 over n, right? Minus, what's that going to give me? 3, so 36? Is that right? No, 4. You're right. I'm missing it. 4. 4. Oh boy, it's going to be, if I FOIL this out, 2n squared plus 3n plus 1 over n squared. So I got an n there, an n there. Everybody with me? Okay. Minus, yeah, minus 4, good. And n squared plus 2n plus 1 over n squared. So I've got an n there times an n there. Does that all make sense? There's a 1 there. Wow, these things get long, don't they? Okay, so, but it's getting better. So I got my 52 minus. Now, if I break that up into separate fractions, I'm going to get 1 plus 1 over n, right? So I'm going to get minus 6. And if I distribute the 6, minus 6 over n. Everybody buy that? Okay. What about here? If I break this up into fractions, I'm going to get 2 plus 3 over n plus 1 over n squared. Right? And we don't even have to distribute the 4. How about if we'll just leave it like that. 4 times the quantity, 2 plus 3 over n plus 1 over n squared minus 4, and then I'm going to get times the quantity 1 plus 2 over n plus 1 over n squared. And now we can start to really clean things up, because what's going to happen when we take our limit?
Everything in the denominator is going to be 0.
Yeah, good. As n explodes, the denominators of all those fractions with n, powers of n in the bottom explode, and the fractions go to 0, right? So that's nice. Now he goes away, he goes away, he goes away, he goes away, he goes away. And all we're left with then is 52 minus 6 minus 4 times 2. Let's see, minus 4. That's our answer. So what do we get there? 18, 30, 34? So that's the area under the curve. About there. About there. Okay? That's a process, isn't it? It's a bit of a process. I'm not going to make you do a ton of those, but like I said, that process is actually a pretty important one in calculus, because it's the same process that you'll repeat every level of calculus as you get more complicated elements. Right now they're just little area elements under a curve, but someday there'll be volume elements under a surface, or there'll be elements of work under physics, under a force time curve or something like that. It's the same kind of an idea. Now, the good news is on the way. Yeah, when you finish up this 4-2 assignment, I've I've got a shortcut that would allow us to do, just, let's kind of look back over our work. Would allow us to do all, what? All that stuff. And I'm gonna say, after you practiced it for a couple days, it's probably gonna take you about 40 seconds, maybe 35 seconds to do with this trick. So I do have a good trick for you coming up. Okay, so help is on the way, but you gotta muddle through a couple of these just to get used to it. All right, so let's go ahead and go someplace and work.